So the presentation that I'm going to be giving today, it's going to cover some of the integration work that we're doing around Puppet and OpenStack. I think the most descriptive name that this presentation could have is really what I've been up to this year. But I'm calling it here Puppet OpenStack Love Fest. This is, I think, us giving OpenStack notice and love, and in particular, allocating a resource, which is me, to understand, how do we integrate with OpenStack, but more importantly, how do we build a community so that we can ensure that whatever work that we do survives. So my name is Dan Bodie, and I'm pretty much Bodie PD everywhere. If you want to see what code projects I'm working on, GitHub, Twitter, I'm pretty awful at, but you can follow me. I tweet once a month. So I actually don't cause that much noise in your stream, which is probably good. And also in Freenode, always there, always happy to answer questions, always hanging out in Pound Puppet. So I'm going to start with a pretty quick introduction of what is OpenStack. And I was laughing with someone yesterday. I'm going to try to get through this without saying cloud, besides that one time that I just said. And this isn't really intended to be a session on what is OpenStack, so it's going to be a pretty brief introduction just to what actually is OpenStack. So OpenStack is an open source project, and it's based on something called Nova, which was called Nebula, which was originally written by NASA, and it was later kind of identified by Rackspace as the technology that they wanted to build their next generation cloud on. Oh, I said it. Basically, something that would translate to Amazon Compute Service. Amazon's Compute Service. But they had this really great idea to say, well, the cost of developing this thing is going to be tremendous. So would it be possible for us to actually create an open source community? And the way that they did that actually wasn't an option for us at Puppet Labs. They spent probably about $10 million or more on marketing. And they did research and kind of selected the best of breed open source solutions that they could find, figured out what the gaps were, but mostly Rackspace just spent marketing money to say, OpenStack, 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 everywhere. And the effect was tremendous. The effect was it actually got attention, it got developers, and it got the momentum that it actually needed to be successful. So OpenStack really is, think self-service APIs for your infrastructure. The question is, how do we get easily from hardware to APIs that I can use in order to automatically provision machines? So something like building EC2 in your own data center. And OpenStack is composed of a few core components. And I'm just going to go through those briefly. There's Nova, which manages the compute instances. Glance is the image service. Keystone manages everything identity, authentication, authorization related. Horizon is the dashboard. Swift is the object store. And those are really the projects that make up OpenStack Core right now. There's a lot of up-and-coming projects. Like I know Quantum, they're actually splitting out networking from Nova into its own project, which will be called Quantum. Cinder is getting a lot of attention in the community right now. That's the specific project for abstracting volume management. And just a couple of graphical representations of really under the core what these things are, under the covers what these things are, starting with OpenStack Compute, which is called Nova. And its main responsibility is it schedules the allocation of resources. So I have this hardware, they have all these resources. Resources are basically disk, RAM, CPU. It has a scheduler. Everything communicates across a message bus, and it has a scheduler that schedules volumes, that schedules instances. How do I create a virtual machine? How do I destroy a virtual machine? It also manages network. How do I associate or disassociate floating IP addresses? And also volumes. How do I create volumes? How do I attach volumes? But the real thing that Nova does is it provides APIs for managing compute resources. Think of it as a hypervisor manager. So the next project is Glance. And this is the service that stores all your collections of images. And in EC2 terms, think AMIs. You know, what images can I use when I'm creating virtual machines through Nova? And it's comprised of the registry service, which holds all the information about those virtual machines, and also the capability which can use to store those images. And it has a few supported backends. The default one is files. Just store all the images as plain text files. It also supports Swift, which we'll talk about, which there's actually not slides for. And again, the APIs are basically store this image, retrieve this image at a very simplistic level. So Keystone manages authentication authorization. And really here, I'm just showing really how that's separated in Keystone is we have this idea of tenants. It's intended to support multi-tenancy. You have users. Users are associated with tenants. Users have roles. Am I an admin? Am I a user? What things can they do? And you also have endpoints, which represent the actual APIs for the individual services. And with Keystone, really what you do is you say, you know, here's my authentication information, and then Keystone will return the roles that are associated with you, but it'll also give you a token that you can use for subsequent communications. It's basically just handling authentication and authorization for OpenStack. Horizon, just a real simple web application for interacting with the various OpenStack components. You can actually use it pretty simply to, you know, once you've installed and configured OpenStack, to create and list and destroy virtual machines, to create volumes, to attach volumes, to deattach volumes, to assign IP addresses to tenants out of the IP address pools to assign them to machines. And it's actually quite functional. It's actually quite nice. So the last thing which somehow slides didn't wind up in here for is Swift. And Swift is the remote object store. And basically, it handles replication of objects. So you may say that, you know, my policy is I need 3 replications of every object. And then Swift will handle that for you to ensure that, you know, detect failures on disks and ensure that the objects actually have the correct number of replications. So I think for our purposes with Puppet Labs, you know, our most important question is why integrate? You know, what are the reasons that it actually makes sense to integrate Puppet with OpenStack? And the first one is that Puppet provides a lot of value to OpenStack because OpenStack's complicated. And I love this diagram. This is kind of an example deployment diagram. And, you know, given what I know about OpenStack now, this is actually a fairly simplified view of what an OpenStack deployment might look like. But there are tons of roles. And I talked about Nova and Glance. Each of these things has 1 to 7 roles that can belong on any machine. And this is a massively complicated application. It's also something that's extremely pluggable. All these components are pluggable. Their subcomponents are all pluggable and extendable. And that's, you know, one of the greatest things about OpenStack, the fact that it has this large community, the fact that people are extending it and making it work with every hypervisor and every volume manager and every SDN networking capability, it also means that it's really hard to configure because there's so much flexibility in the system. And that's where Puppet, I mean, that's our bread and butter, is you express these things in Puppet, and now you can be sure that you can build them reliably and repeatedly. You know, once you've specified the Puppet configs, you can just build those things over and over and over again. Oh. Wow, duplicate slides. So the next one is kind of how does, you know, OpenStack actually makes our lives at Puppet Labs a little bit easier. At Puppet, we want to automate everything. We want to make it easy to automate all of your business applications. And OpenStack actually makes that easier because it allows you, for bare metal, to implement this single application that itself serves as a self-service API. And having a self-service API actually makes automation easier, right? Because the configuration management can programmatically interface with a self-service API to perform provisioning on the fly, which means that it actually makes it easier for us to fully automate infrastructure. And kind of going towards, I think the most interesting thing is that since Puppet is a language that people know, and especially sysadmins know, it's a great place to share knowledge. And not to share knowledge within an organization, but to share knowledge between organizations about how do various companies deploy OpenStack. What are their best practices? And it's not just OpenStack, it's also highly available OpenStack, monitoring of OpenStack. And for me, this is really one of the most important value adds is, you know, that's I think what people really want is they just want this box that they can just grab off the shelf that says this is OpenStack, this is going to work, and it also includes methodologies from these various companies that are participating and codifying their knowledge in this central repository. So now I've talked a little bit about what is OpenStack, talked a little bit about why it makes sense to integrate, both in terms of how it's advantageous for our objectives, and also the fact that it's just another application to us. And that's our bread and butter, is automating application installations. And I know it's been kind of a reoccurring theme that, moving forward, we see that our other bread and butter is working with community, working with open source, and teaching and encouraging people to collaborate together so that knowledge, it feels like at some level knowledge has already gone from the internal wiki to Puppet, and we think the next logical step is into the forge, out into the wild, for people to become better at using open source to collaborate on best practices for deployments. So part one of creating the actual OpenStack modules is create a community. And from our perspective, the last thing that I would want to do is spend time working on code that's going to die a terrible, cold, lonely death because of neglect, because I have other things to do, but most importantly because it is unlikely I will ever be responsible for managing a production OpenStack environment. So therefore, I have a lot of skills for understanding how to organize things, how to use Puppet. But I definitely need the help of the real experts, need the help of the real people that are incentivized to actually help maintain this code in the long run. So now that we've said it makes a lot of sense to combine Puppet with OpenStack, and we want to do it, we're not experts, so we want to build a community. And I think the logical way to start building community is to sit and write some code, right? At least give a starting base to say, here's some code that hopefully will get people excited, get people interested. So how do we do that? So the first thing is create classes so that we can have these higher level configuration interfaces for all the actual OpenStack components. And we all know we have these primitives we have packages and groups and users and these various things. So step one, figure out all those things, figure out how to install OpenStack, and create these higher level configuration interfaces. So we can think of things at a higher level. As opposed to thinking about packages and groups and users and services, I'd rather think about, here's a service, what port am I going to bind it to? What's the URL I'm going to bind it to? And we need to do this for all of them, right? So there's actually a large number of things that needed to be modeled. And one of the great side effects of this project is I actually spent a lot of time on RabbitMQ module, on a MySQL module, even on an app module. And even these modules independently from OpenStack are also gaining traction as well. And then the next thing is to take all these building blocks and then start to compose them into these higher level roles. And for my purposes, the most basic roles in OpenStack are, we have some role called a controller, and we have some role called a compute instance, right? Where you can think of compute as being the hypervisor, where you have resources to manage, and the controller is actually just going to do the management. And the reason that I created these higher level interfaces is because that's actually probably what 80% of everyone wants. But the nice thing is they're composed of all these subcomponents, so it also serves as a great starting place for people that want to compose their own n number of roles for OpenStack. And during this process, one of the things that I found challenging and that really challenged me was, how do you design with community in mind? And this is very similar to, well, this is maybe what's a little bit different between my presentation and Al's, is that it's more about how do you design maybe to get it done. My design concern is, how do you design things so that people can contribute? How do you design things in a way that actually encourages contribution? And step number one of that is base everything on small reusable components. That, you know, MySQL is MySQL. And OpenStack uses MySQL, but MySQL should be able to live on its own. And the same thing with the other OpenStack modules. As I said before, I have these very high-level constrained views of what it means to be OpenStack. You can be a controller or a compute. But those are just examples of how you could build your own. And it's all based on these very flexible, very modular units that are down to the lowest level of configuration for OpenStack. The next thing is, if you want people to use this stuff, you need to make them flexible. And this means you need to think of what are the possible things that make sense to configure, and then for each of those interfaces, you know, make sure that you're providing the things that people want to configure. And I think one of the most important lessons that I learned is make it obvious where extensions go. It actually makes me, when someone can add an extension from one of the backends to OpenStack and they put it in the right directory and it has the right name and it looks the same as everything else, like, that actually makes me feel really happy that I've done something right, that people know how to extend this stuff, they know where the extensions go, and that actually makes me feel confident that this project makes sense, that we're actually accomplishing something. And this is just an example of, and it probably seems fairly obvious, but I think it's important that, for glance, you know, if you support multiple databases, make sure that's a directory. Make sure it's organized using namespaces in a way that it's obvious how extensions should be namespaced and where they should go logically in the directory structure. And one of the interesting things, and I've been really happy with the results of it, is just making sure that it's really obvious where additional platforms go. And actually, Red Hat, I've been working closely with Red Hat on a lot of the support, and I also really enjoy when I get a pull request which says this broke on Red Hat. And the pull request is, it was obvious that what I need to add is in this one file, and this is where it goes. And again, this is what I mentioned before during the Q&A session, is thinking about supporting multiple operating systems, especially if they're Linux, if they're all Linux flavored. And thinking of it as an internationalization problem of, let's just segregate all that code to a central location, which gives you two advantages. One is you have a nice central place to look to understand how it's different between those platforms. But the second advantage is it's a lot less risky that I can add stuff related to my platform and not have to worry about breaking the rest of the platforms. So we're going to talk about the next part. That's kind of transitioning out of what does it take to build community, and that's writing code. Some examples of a lot of the things that I kept in mind as I went through the process of creating all that code. But I think an underlying concern that I had, and something that really motivated me throughout this process, is fear the fork. Just aggressively fear the worst thing that could happen would be, I create this thing, that becomes a starting place for 20 people to fork off to and then do their own thing. And this is somewhat of the historical state of Puppet, is that people say this is a starting place. People say, I'll use that, everyone forks. And the ecosystem doesn't get to take advantage of just the sheer size of the community. And I think that in the last several months, this has been something that's been getting a lot better. But I want to talk a little bit about, that this was something critical to me during this process, is I don't want people to fork. And how do you do that? How do you prevent people from forking code that's on the internet? And especially code that's on GitHub with a button that says fork. So one of the first ways that I did it, and it's funny to think that, yeah, 4 months ago I was doing this, is in GitHub there's actually a view of who has forked your project. And you can literally, for anyone who's forked the project, you can click on any commit and you can track them down. And I pestered those people. I said, I had a template email. Hi, my name's Dan Bodie. I saw you had a fork. I think it's an interesting feature. I think we should talk about it. And I literally chased these people down and harassed them until finally, after weeks of harassing emails, polite emails, but harassing emails, they finally submitted their code back. And I was, there's still a lot of forks and still a lot of code out there, but in the early days, I was definitely aggressive about making sure that they weren't forkers, that they were going to be contributors to the project. So the second thing was just being responsive. And I think that I was in a great position and maybe lucky that this was my job. I mean, this is what I was doing for a living for a lot of this year, is chasing those people down, is making sure they contribute, is figuring out how do we create community. So I spent a lot of time working with people, and I think this is an example. Again, this is GitHub interface again. It's an example of me being responsive, of me sometimes even just being an intermediary, of saying, hey, expert that I've been harassing and is helping me now, does this look right? And this is also a great example of a conversation. Here's something, I'm not so sure. I just say, where does it say in the docs? They send me a doc link, and it's merged. So the interesting thing is that there's this progression of I'm harassing people to, people are now submitting code, and I'm being responsive. And the result of that was that tons of pull requests, a pretty reasonable number of contributors, and it's probably 350 merge pull requests on all the projects now. Most of that's me, but the interesting thing in the trending information is much less of it is me as time goes on. And that's exactly what I'm looking for, is I'm looking for it to be more experts going forward. And me in a position of doing merges and helping people understand how to write tests, how to use Puppet. And hopefully my ideal situation is I'm a Puppet expert. I know a lot about Puppet. I would love to be in a position of helping people do it in the best way possible, but ensuring that all the OpenStack experts and users are the ones actually driving the project forward. And I do believe that that's really the way that the project is going to succeed in the long run, is based on the community around that project. So again, this is my kind of unruly mob of committers. And they're nice, they're bringing me a flyer, but it's still daunting to have that many people, that many emails, be tracking that many things. And we're going to talk a little bit about testing now. But I'm going to talk about testing in terms of it is absolutely a requirement if you're going to have community that testing has to be automated. It has to be really, really, really automated, because you have to know, hey, that's great that you care about this platform. Does it break the other platform? And that's great that you want to add this additional parameter for it to be more configurable. Are you breaking anything else? And automated testing is the only sane way to have a community-run project, is to have tests that are saying whether or not commits are actually valid or not. And we're going to talk a little bit about testing in Puppet. And I think, again, at a pretty high level, the first thing that I'm going to talk about at a very high level is our Spec Puppet. And to start, we're just going to talk a little bit about Puppet's model how Puppet works, the architecture of Puppet. And I think this is obvious to more than half the room here, but it's worth kind of going over that this is really the flow of Puppet is, you know, I'm a computer, I'm fairly unhappy, need to be configured. I will send my facts to the master, and facts represent all of the information that's specific about that machine. What is my operating system? How many cores? How much memory? You know, what's my kernel version? So factor is, and facts are how the machines communicate specific information about themselves to the Puppet master. And then the next thing that happens is potentially data is coming in from some external source. Could be an ENC, could be HIRA, could be just a site manifest that we're hard coding a lot of data values so that data actually gets into the classes, gets into our defined resource types. And facts and the data come together through Puppet and generate what's called a catalog. And a catalog is a data structure. The data structure is actually a directed acyclical graph. And it represents the individual resources that we're managing, as well as the edges that represent the procedural dependencies between those resources. So you can think of this as a data structure that describes the desired configuration state for the machine that we're managing with Puppet. So this is Puppet's model. And we're going to talk a little bit about, or I'm going to talk a little bit about, you guys are going to listen hopefully, about our Spec Puppet and how it works in relation to this model. So the first thing we can do with our Spec Puppet is we can emulate facts. So if we're going to test manifests, we have to be able to programmatically inject facts, right? Because, well, sorry, more specifically, if we're going to do unit tests. Because what we don't want to do with unit tests, we don't want to spin up VMs. We'll talk about integration tests in a second. We just want to be able to run a bunch of tests that are going to get coverage over the various ways the code could be broken. And one thing we can do with our Spec Puppet is we can inject facts. When I run this test, let the factive operating system be set to Red Hat. And then I could say, let it be set to Ubuntu, Debian, some other system. So we can inject that programmatically. So the next thing we can do is we can inject data programmatically as well. And whenever you write RSpec Puppet, you're testing either a defined resource type or a class. So for that defined resource type, for that class, let some parameter. And in this case, we're saying, let the operating system be Red Hat. Let this parameter be that rabbit host is 10.0.0.42. So the last thing we do is we actually inspect the catalog. So remember, with Puppet, we always start with code, but we generate this intermediary data structure. So we can actually analyze that and say, all right, when the fact was set to this, when the parameters are set like this, it should generate a catalog, and that catalog should contain this file. That file should have this line. And this is far from perfect in terms of testing, but it's extremely valuable. What you're really testing is, given some input parameters, some facts, given some parameters, some class parameters, defined resource type parameters, are the resources actually correct? Does the catalog compile? Are the resources correct? And are those resources there? What this doesn't actually test is, can it actually deploy a functional service? But the great thing about unit tests is we can throw them into a continuous integration platform. This is actually, I took this yesterday on the train. This is the current state of the Jenkins view, the view in Jenkins of all of the unit tests running. And the great thing about all these unit tests is once we've done all this stuff with facts, with parameters, now we can just create a matrix. And this is what Jenkins does. We can say, hey, in my matrix, let's test these 2 versions of Ruby. Let's test these 6 versions of Puppet. And it actually creates a large amount of coverage. And from my perspective of working with community, it's a very, very, very important way to gate pull requests, that I can automatically know immediately if someone's commit broke something in a very simple way. And we'll talk about integration tests, yes.
Just a short question. How do you measure coverage?
I am not, I know all the code, so I have a reasonable mental image of the parts that are lacking coverage. You know, I would say that in the Puppet ecosystem, a lot of the tools like this, I think our community understands the need for this stuff, and these tools are evolving pretty quickly. I don't know of any test covering software specifically for Puppet, but I would be surprised if something doesn't exist by the end of the year, hint, hint. But no, I know, and I actually have tickets open in a database to remind myself of the parts that are missing coverage. And especially early on, I was not perfect with my coverage, but yeah. The coverage is probably around 80%, would be my guess. And I know that in particular, the Keystone native types are the worst. They are probably like 18 of that 20%. So this is a lot of really great information. The other thing this says is we depend on a lot of other projects, and I'd like to keep as current as possible. We're also tracking a lot of projects that aren't specific to OpenStack. We're tracking rsync, MySQL, apt, xnetd, and a lot of people are actually merging pull requests. You know, those things aren't directly associated with OpenStack, but I do want to track master, and I do want to make sure that nothing's changing in those things that's going to break anything else. So the last thing I'm going to talk about is integration tests, and this is my one slide that's very similar to the last presentation we saw. And this is just kind of a basic idea of integration tests. And full disclosure, we're almost done with this part. But the basic idea of integration tests is, you know, all that spec tests are doing is verifying that we can get a data structure that looks right. What it's not verifying is this actually a functional OpenStack installation? We're in the process right now. It's still restricted to vwe vagrant for the workflow for doing this, but we have an automated process now for, you know, knowing when code changes. Eventually, it's going to be tied into Jenkins, but the idea is if the code changes for any of these projects, the ones we just saw, then what we want to do is we want Jenkins to fire off a job which is going to build out an OpenStack environment. And let's say we start with a single node environment of an all-in-one installation. And eventually, once we can get Tempest to work, and I would love help there if anyone can, once we can actually get Tempest to pass, which in theory it does, then, oh, by the way, Tempest is the actual integration suite of OpenStack. And the point of this test is, every time the code changes, have Puppet fire off a job in Jenkins, sorry, have Jenkins fire off Puppet in order to build out a real OpenStack environment in our lab. And once that environment's built, use Tempest, which is the actual integration test for OpenStack, to verify that it's functional according to the specification of Tempest. And the last part is, if there are things that are missing from Tempest, add them to Tempest. Tempest should be the authoritative place where all the code related to the question of answering the question, is this functional, goes. So we're pretty darn close to having this working. It'll be initially just for all-in-one installations. We'll be targeting all-in-one and then split controller computes, and for probably just initially flat HCP networks, eventually. And then also separate tests for Swift multi-node builds. And we're just a couple weeks from having all that stuff set up. So just talking about the next steps of community building. So we've gone through, you know, why we've integrated, how we started, how I've designed things with community in mind, the importance of testing, some of the success we've had with community. Now we're talking about next steps. And my next step is really that I think the project works, and I think it's definitely in a place, and that I'm in contact with enough community members that now what I really want to spend my time on now is just connecting those people and asking the next question of, you know, can people actually agree on what monitoring should look like? Can they agree on what HA should look like? And I know that I'm going to be in the next week sending personal emails to people and encouraging them to have these conversations on the mailing list. And right now there's a Puppet Labs-OpenStack mailing list. But I'm also open to questions of, should that be on the OpenStack administrators mailing list? But this project feels a little bit separate from OpenStack now, but I would be happy if this just became part of OpenStack. That would make me ecstatic, actually. But I think we would need to have definitely a lot of community pushing for that within OpenStack. And then, you know, another thing that I haven't done yet, which I'm actually pretty close to, is granting merge rights. I would love for the community to have merge rights. And let's say that if in the next 4 or 5 months, if if I had 4 or 5 people that had merge rights, I would be ecstatic. But I think that, you know, people are going to have to earn merge rights. They're going to have to show that they're going to write tests, that they're committed to these things, that they're going to be watching if there's build failures. But from my perspective, if the code's reasonable, if it follows similar style to how the code's written, if it has tests, you know, and if people can show that that's how they're going to code and that they take this stuff seriously, I am so happy to grant them merge rights. So I'm going to talk about another requirement that was part of the OpenStack project, and I know Teo mentioned this briefly in his presentation, and that's Razer. And for us, Razer was a very important requirement, and I can definitely say that the requirement of having tight integration with a bare metal provisioning system was a requirement for the OpenStack project whenever Razer was just an idea, when it was just being designed. And the reason is OpenStack should be on bare metal, right? This is all about building out self-service APIs, but building that on top of another layer that had self-service APIs would seem kind of ridiculous for anything other than testing. And since OpenStack, so to talk just a little bit about Razer, and this is probably just reiterating some of the things Teo said this morning. What Razer is it's something that manages the Pixie state process, except it always has an initial state for all machines, and that state is that they'll pick up this little micro OS that's running Factor, so that as the machines come online, they automatically populate all their facts. And the guys at EMC, we wrote Razer in collaboration with EMC. Those guys wrote a lot of custom facts for gathering tons of all the information they could even think you would need about what disks and, you know, various hardware connection information, BMC information. And so all the machines automatically discover themselves and populate themselves into a database, and then you have APIs that sit in front of that. So as soon as you turn on machines, you have API access about how those machines should be configured, what OS should go on them, and it has some integration with Puppet to specify classification information, even though that's in the very, very, very early phases of development. And this has been a really, really interesting theme since I've been in business development, is it seems to all be going towards reference architectures. I think that's what the world wants, and I think that's a lot of what people are looking to us to figure out is, you know, let's say I buy 2 blade centers. The reality is I'm actually trying to buy some stuff to run an application on. So it seems like our problem in the long run is how can we just have some code, some Puppet manifests, so you just turn those blade centers on and they just become whatever you bought them for. And that really does seem to be in business development where all of our partners are looking forward to. And that's why Razer is very important, because from perspective we have hardware, we want to start with Razer using Factor to get it to a state where it can tell Puppet how it's classified, so you can just go straight from hardware to the OpenStack in this example, but really to any infrastructure as a service layer. And then once that's there, that really gets us excited, because that's our bread and butter, is you give us some provisioning APIs and we'll write some cool automation software, because we've already solved the hard part, which is the actual configuration management of the machines. And there are some other parts that need to be solved, things like cross-host dependencies, and there's going to be some things that we're going to be working on towards the very top of this layer in the future. So I'm probably fairly short on time, but I think, oh, there's some links. There's a blog talking about how to get started if people are interested. Modules are on the Forge. People want to contribute. They're also on GitHub. So maybe I can, what is that? Maybe I can ask a few questions, or no. I have maybe a little bit of time for a few questions. It's the opposite of what I meant. Teo, you have a question?
No, I was going to say maybe 5 minutes. So that's a little bit.
That's a statement, not a question.
So that's a statement. I said it was 5, not asking.
Oh. Great, no questions? Thanks, everyone. Oh, there's a question.
I didn't see any of the earlier Puppet stuff. With OpenStack, one of the problems I came across was you turn on
We are, the question is, there's potentially BIOS configuration that needs to occur. And right now, that's some of the work that EMC is very focused on with Razer right now, is being able to configure the BIOS. So I would say that it's something that's on our radar. And honestly, to get here, there's a couple parts that I left out. And we're in conversations, again, business development, with people about how to solve those problems. And they include configuring BIOS. It also includes how do you automatically set up networking gear. And what a great time to be solving that problem with SDN and software-defined networks emerging now in the marketplace. And any other questions? Great. Well, thank you, everyone.